Now let's see this example 5.1 in which we are going to design a system, grading system, which connects 20 trunks to switches having 10 outlets. 10 outlets means we have 10 columns over here. So the number of graded groups given by equation 5.3 is G is equal to N over G is equal to 2N over K. So 2 into N, which is 20, divided by K, which is the availability, which is 10, which is taken as 10 because we have got 10 outlets here. So 10 columns here. So 2 into 20 divided by 10 gives us 4. It means that we'll have 4 lines or the 4 groups, and the factors of 4 or G are 1, 2 and 4. So the number of choices of having singles, just like in this case here, the number of singles is here, the number of singles column is 1. Here the number of partial commons are 1, 2, 3, 4, 5, 6 and 7. The number of all commons or full commons is 1 and 2. Or we can say these are quadruples and these are doubles. These are singles. So the number of choices having singles is S, number of choices having doubles is D, and number of choices having quadruples is Q. If we substitute in equation, these values in equation number 5.4 and 5.5, which we have already seen, and 5.4 is the total availability is equal to sigma, or the summation from I is equal to 1 to Q of Ri. Ri is number of singles, doubles and quadruples. So R1 is singles, R2 is doubles and R3 is quadruples, which is 4, right? Which is quadruples, which is the number of quadruples, which is Q. Similarly, in equation number 5.5, we get the total number of trunks in this case, which is the summation of Ri G divided by Fi. What is Fi? F is the factors. When I is equal to 1, Fi is equal to 1. When I is equal to 2, Fi is equal to 2. And when I is equal to 3, Fi is equal to 4. So we have got 3 terms in this case because we have got 3 factors of 4. This is the equation 5.5. From these two equations, we get these equations. S plus D plus Q is equal to K. K here is 10. S is the number of columns with singles. D is the number of columns with doubles. And Q is the number of columns with quadruples. If we add all these columns, we get 10, which is K. K is the availability of this system. Similarly, if we put this in the put it in the in equation 5.5, we can say we can get the next equation, Ri G Fi, and taking sigma of it, or summation from I is equal to 1 to Q equal to N. I have calculated it separately also. You can see from this equation. Here G is equal to 2 into N over K, and 2 into 20 over N is 4 groups, and then number of choices having singles is S, number of choices having doubles is D, number of choices having quadruples is Q. From equation 5.4, sigma Ri is equal to K, which is R1 plus R2 plus R3. We only go up to 3 terms because we have singles and doubles and quadruples only. So that would be equal to 10, which is equal to K, or availability. Right. Now from equation 5.5, what happens is that the equation is sigma I is equal to 1 to Q Rig over Fi, which is equal to N. F1 is 1, F2 is 2, F3 is 4. We put these values in this equation. R1 into 4, which is the number of groups, divided by F1, which is 1, plus R2 into 4, which is G, number of groups, divided by F2, which is 2, plus R3 into G, which is 4, number of groups, divided by 4, which is F3, which is 4, or the third factor of F, the third factor of G, which was 4. So 4 has 3 factors, 1, 2 and 4. They are used over here. That would be equal to the total number of trunks, which is 20. Now in this case, R1 is equal to S, which is the columns with singles. R2 is equal to D, which is the number of columns with doubles. And R3 is equal to Q, which is the number of columns with quadruples. When we put these values over here, we get 4S plus 2 and 4 are cancelled, 2 into D plus 4 and 4 cancel, we get R3 is equal to Q plus Q is equal to 20. Now subtract equation 1, this equation, from equation 2. 4S minus S is 3S, plus 2D minus D is D, plus Q minus Q is 0. So we get rid of the value Q, equal to 20 minus 10 would be 10. So we get a third equation. Now we've got these 3 equations. Using these 3 equations, if S is equal to 1, let's see what would happen if we have S equal to 1, or the number of columns with singles is 1. Then from the above equations 1, 2 and 3, we get D value equal to 7. How can we get that value? Simply from this equation. If S is equal to 1, then D would be equal to 10 minus 3S, or 3 into 1. 10 minus 3 would be 7. So D is equal to 7. And with putting this these two values, we can get the value Q equal to 10 minus 8 equal to 2 from the first equation. Similarly, if S is equal to 2, D is equal to 4, Q is equal to 4 also. When S is equal to 3, D is equal to 1, Q is equal to 10 minus 4, that would be equal to 6. S is equal to 3, D is equal to 1, Q would be equal to 6. But if we put S equal to or greater than 4, that is not possible. Reason being the fact that 3S plus D is equal to 10. If we put a value equal to 4 or more, in this case, if we put 4 here, it would become already 12. And if we add, and if even D is equal to 0, this equation will not hold. This equation will not hold. Let me think, I missed it. This equation will not hold. So we have to move to restrict ourselves to these 3 cases. S1 is S is equal to 1, S is equal to 2 and S is equal to 3. So in these cases, we have to find the sum of the successive differences. from equation, it is given in equation 5.6 on the book. D1 is equal to R1 minus R2 plus R2 minus R4. Take the first case. Here R1 is S, which is equal to 1. R2 is equal to D, which is equal to 7. R3 or R4, you can call it R4 because this is the third factor. It is Q, so which is equal to 2. Putting these values, D1 comes out to be S minus D plus D minus Q. So 1 minus 7 plus 7 minus 2. This will be minus 6 since it is in modulus. We get the positive value here, 6 plus 5 is equal to 12. For D2, we get the value in the similar way, S minus D plus D minus Q. 2 minus 4 plus 4 minus 4. So minus 2 comes in modulus, it becomes 2 plus 0, it becomes 2. D3 is S minus D plus D minus Q. Take the third case, S equal to 3, D is equal to 1, Q is equal to 6. Now what happens? 3 minus 1 plus 1 minus 6. 3 minus 1 is 2, 1 minus 6 is minus 5. Within the modulus, open the modulus, we get plus 5. 2 plus 5 is 7. Now compare these three values of the differences. The least value is selected. D2 is the least, which is 2, as compared to 11 here and 7 over here. So D2 is the best choice. That's how we select the best or the optimal grading system in a switching network. Now what would happen if we have to increase the number of trunks? For example, if the number of trunks that we have been studying earlier, which was 20, it has to be increased to 25. What would happen? How can we do it? If a growth in the traffic makes it necessary to increase the number of trunks connected to the grading, this can be done by reducing the number of commons and partial commons and increasing the number of individuals. So here we selected this second case in which we had S is equal to 2, D is equal to 1, 2, 3, 4, and Q is equal to 1. And Q is equal to 1, 2, 3, 4. Q is equal to 1, 2, 3, 4 here. And we have implemented it in B part. If we have to increase the total number of trunks from 20 to 25, what would happen? We would increase the number of individuals and individuals by reducing the number of commons and partial commons, just like we have done over here. In this case, from two individuals columns, we have increased it to 4 individuals columns, and we have reduced the partial commons from 4 to 3, and we have reduced the all commons or the quadruples from 4 to 3, right? In this way we are able to complete this distribution of 25 trunks. You can find this out: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. In this way, 25 trunks are adjusted. In addition to this type of grading, which is the progressive grading, we can have other forms of gradings also. One form is called the skipped grading, in which these are partial gradings but not not always in the same way that was done earlier. Not the first and second groups are taken column. Maybe in some cases we have first and second are taken common, and third and fourth are taken as common. And in other columns we have first and third are taken column, and taken column common, and second and fourth are taken as commons. Here the situation is a little bit different. First and fourth are common, and second and third are common. And here also first and second are common, third and fourth are common. There is another method of doing this, having a grading system, which is the homogeneous grading. In this you can see that we have partial commons over here, and see the format of partial commons. This is also a partial common, this is partial common, but all the partial commons are different. All are partial commons, but the choice of the groups is different. Here first and second are common, third and fourth are common. Here first and third are common, then second and fourth are common. Here first and fourth are common, and second and third are common. This is the homogeneous grading. Now let's see, let's come to the next part.